Hey gang, it's Mr. Falcone here again. Just going to walk you through sort of the basic steps of how to do the mineral identification lab. So let's go ahead and jump right in. Now first of all, you can't do the mineral identification lab without a mineral identification index. This is just a handout that you're going to get in class that will give you all the physical properties of each mineral and it's divided up into three sections. The first section is minerals with a metallic luster. The second section is minerals with a non-metallic luster but generally dark colored, and then the third section is non-metallic minerals that are generally light colored. So you have to have this mineral identification index with you before you get started. And of course you'll need a mineral sample to look at. Now what mineral is this? Who knows? It could be anything, but finding the identity of this unknown mineral is the task at hand. First thing we want to do is determine its luster. Is it metallic or non-metallic? Should be fairly obvious that this is a non-metallic mineral. And then is it dark colored or light colored? Definitely going to be light colored. So we want to put this in the non-metallic light category. So we're going to note that on our lab sheet. So here we have the mineral sample is number 10, and that's just written right in the box where the mineral is, and we're going to put NML, the initials NML, for non-metallic light. If it was dark colored but non-metallic, you would put NMD, or if it just had a metallic luster, you would put M. Once you have the luster written down on your data table, you have to figure out the hardness of the mineral. So the first thing you want to try to do is see if you can use the mineral to scratch a plate of glass. If it scratches the glass, then you can go ahead and try to scratch the mineral with the tip of a nail as well. And if it can't get scratched, or if the mineral can't scratch the glass, then you may as well try to scratch it with a penny as well. Okay, so I run all the hardness tests with the glass and the nail and the penny, and it turns out that the mineral cannot scratch the glass, so we're going to go ahead and say that it's softer than glass. Remember that hardness, you're going to really get three different results. It'll either be harder than glass, softer than glass, or about the same as glass. In this case, the mineral sample was softer than glass. Then it's time to look at the mineral again very closely, and you want to determine, does the mineral have cleavage or does it have fracture? Remember that they're sort of opposites of each other. If the mineral has been broken and you can see smooth flat surfaces, then you say it has cleavage. If you don't see any smooth flat surfaces, if it's rather rough and jagged, then you say it has fracture. In this case, this mineral definitely has some smooth surfaces on it, so we're going to go ahead and say that it has cleavage. Now, having determined that this mineral sample had cleavage and not fracture, we're going to note that on the data table. And then we're going to look at it at the mineral, and we're going to determine its color. Here, in this particular case, it's kind of obvious that it's white, so we're just going to write white in the color column. One other test that's commonly done on minerals to help identify them is to put a drop of acid on the mineral and see if it will react, bubble or fizz, or sometimes you'll see the word effervesce. So let's give that a try. So grab your bottle of hydrochloric acid and just put a drop right on the mineral. Be careful and make sure that you only put one drop. And on this particular sample, you can kind of see the bubble and fizz. So this sample definitely does have a reaction with hydrochloric acid. So we're going to note that on our data table. Now one last test that we run is the streak test, where we take the mineral and we just rub it once on the streak plate. Let's see what we get. So we do that, and we can see that the streak on this is white, which is something else that we can include on the data table. Now let's check back and look at the index. Checking with the index, we can find the physical properties that match the mineral that we found, or the mineral that we looked at, and we can see that its identity is calcite. So we're going to note that on the data sheet. So here we have that line on our data sheet completely filled, and then we're all set, and we're going to move on and do the other 10 minerals. And finally, if I wanted to incorporate Twitter into my assignment, I could take a picture of the mineral sample with my phone and send out a tweet to my students asking them to try to identify the mineral just from the picture that I tweeted out, and they can include that information